Today we're working on section 6.2 and we are talking about multiplying polynomials. So we're going to start out with just multiplying a monomial, which is one term, and a polynomial. And as we do these, even though the directions do not ask us to name them, we're going to practice naming them by degree and number of terms. Alright, so all we're going to do is we're going to distribute that monomial to both terms inside the binomial. So you take your number times your number, we're going to keep that 4, and we multiply the bases. The rule is to add the power. So y to the second times y to the second becomes y to the fourth. That is based off of the rule of a to the m times a to the n is equal to a to the m plus n. So an old power property. Now when I take this 4 times positive 3, I keep the positive 12, and I just tack on that y squared. And that is it. And we would name this, by degree 4, it would be a quartic. And since there are two terms, quartic binomial. All right, the next one, we're distributing a 3x squared. So we have a 3 times 1, we keep the 3. X squared times x to the third builds to x to the fifth. Then bring it over to the next term. 3 times positive 4 is positive 12, x to the second. Here we have a fifth degree, so we would call this a quintic binomial for two terms. All right, this next one, we're multiplying everything by fg. So what you're going to see is everything is going to have a power increase of 1 on each f and each g. Also watch your sign. So here we have f to the fifth and keep just g. And then we're going to take it here, so it's going to be a positive 2, f to the fourth, g to the second. So everything's getting an extra f and a g. Next term is going to be a negative 3, f to the third, g to the third, and our last term is going to be positive f squared, g to the fourth. Now if we have this in standard form and you have two variables f and g, standard form is that you keep the variables in alphabetical order. So f is the first letter of the alphabet, so we keep that in order. So power 6, power 4, power 3, power of 2, and then the g's just go along with it. All right, in this one, we have our monomial out front has a degree of 6 and a degree of 1. So this would be a 7th degree, and we don't have a specific name for that we're using, so we're going to call it a 7th degree. And because it has 1, 2, 3, 4 terms, we are just going to call it a polynomial. So 7th degree polynomial. So that's a real basic idea of distributing a monomial to a polynomial. All right, next we're going to get into something a little bit harder than FOIL. So you can see I have 2 terms times 3 terms. I can also see that these terms are out of order. So you have the option of rearranging them. I'm just going to multiply as it is and then clean it up. There are several methods for doing this. You can use a box method. You can stack them vertically. I'm going to go ahead and do this one where I just extend it out. So I'm going to come through and I'm going to take the x times all 3 terms. I'm going to focus on that and I'm bringing the negative 2 back later. So x times 1 would be x. X times 3x would be positive 3x squared. X times negative x squared would be a negative x to the third. All right, once we do that, we're going to come back and multiply everything by negative 2. So negative 2 times 1 is a negative 2. Negative 2 times 3x is a negative 6x. And negative 2 times negative would be a positive 2x squared. So I should have 6 terms. Here's 3 from the first piece. And I think I screwed up. No, and 3 from the second piece. So we have this and we have these here. Okay. So when we look at this, we add like terms. So I have my highest degree is x to the third. So I have a negative x to the third. And then I have my x squared. So 3x squared and 2x squared becomes a positive 5x to the second. All right, next would be x to the first. So 1 and negative 6 will be negative 5x. And then last would be our constant, which is negative 2. So here is what we have once we've cleaned it all up. And we would name this by degree 3, so it'd be cubic. And since there's more than 3 terms, it's a cubic polynomial. So again, I chose to distribute the first term, distribute the second term, and then just write it all out horizontally. If I run out of room, I'd have to continue on. This one is going to be a little bit more work because I have a quadratic trinomial times a quadratic trinomial. So I am choosing to stack this. Notice that they're in order. Again, you can write it out in one big line, but I'm going to go ahead and make some lines here. So I'm going to take this y squared times all 3 terms. So that would give me y to the 4th. And then I have y squared times negative y, so negative y to the 3rd, and y squared times negative 3, negative 3y squared. All right, I'm going to come back and I'm going to do a second line, and I'm going to multiply everything by negative 7y. So coming across here, and I'll deal with the 5 last. So negative 7y times y squared is going to be a negative 7y to the 3rd. So notice I paired it up and I put it right under my y to the 3rd. I can only do this if I have a consecutive power of 2, 1, and 0, and they're in order 2, 1, and 0. All right, so negative 7y times negative y is going to be a positive 7y squared. So that's going to line up. And then negative 7y times negative 3, positive 21y. You want to take your time and do your signs, your numbers, and then your variables. Break it into 3 ideas. All right, last thing I'm going to do is take this 5 times everything. So 5 times y, 5 times negative y, and 5 times negative 3. And so 5 times y squared is going to go right here. It's a positive 5y squared. And then 5 times negative y is a negative 5y. And then 5 times negative 3 is a negative 15. So whether I did this vertically or I made it one big line, I now need to go through and find my like terms. The highest degree is 4, so y to the 4th. My next highest degree is 3, so find all your powers of 3. Negative 1 and negative 7, so negative 8y to the 3rd. I have my y squareds. So here I have 4y squared plus 5, so 9y squared, y to the 1st, and I end up with a positive 16y, and last my constant of negative 15. All right, so I see that my highest degree is 4, and I have more than 3 terms, so this is going to be a quartic polynomial. All right, after doing those 2 long problems, we've got this nice short one, which is a binomial times a binomial. And so all I have to do here is practice my old rule of foiling. But when I foil, do you notice when I say I'm going to take my first times first and then do my outside, I'm really just taking the 3x and distributing it. FOIL is just an acronym to help us. So 3x times 2x is 6x squared. And I have my 3x times my outside negative 7y. So I get a negative 21xy. Then I do my inside and my last. So when I use the acronym FOIL, I am doing no more than distributing the first term, distributing the second term, just like we did here. All right, so negative 8y times positive 2x is a negative 16. I'm going to go ahead and make it xy. And then I have my negative times a negative, so I get a positive. 8 times 7 is 56. And notice that it is a y squared. So I do have 2 like terms here. I'm going to keep the 6x squared. And I have a negative 21 and a negative 16, so I get a negative 37xy. And then my positive 56y squared. The highest degree is 2. Actually, all of these monomials have a degree of 2. All these terms have a degree of 2. So it is going to be a quadratic. It's going to be a quadratic trinomial. All right, take a look at this next example, and I want you to think about how you want to attempt it. Common mistakes, and I don't want you to write this right now, but one of the common mistakes that we see on this problem is that people want to distribute. So again, this is incorrect, but I want to show you why. we cannot distribute this power of 2. There's no rules that allow you to distribute a power of 2 over addition and subtraction. So if you chose to do this, you'll get the 4x squared, and if you square this, you'll get a positive 16y squared. That is not the right answer. So let's compare it and show you what should happen. So we cannot, this is incorrect. We cannot distribute a power over addition and subtraction. What we need to do is when we see something squared, we know we need to take it times itself. So I'm going to actually write 2x plus 4y times itself, 2x plus 4y. And I'm going to FOIL that. So when I go to FOIL this, the 2x times 2x, that still gives me a 4x squared. So same thing I had. But now I take the 2x times 4y and I get a positive 8xy. And then I do the inside and I get a positive 8yx or xy. Multiplication is commutative, so yx and xy are the same. And last I have 4 times 4, and don't forget the y squared. When I go to put this together, I add like terms. So I get 4x squared plus 16xy plus 16y squared. So while we're here, let's name this. Again, every term has a power of 2, or a degree of 2. So this would be a quadratic trinomial. So let's compare our answer to the mistake. If I look at this mistake, and I had just distributed this to both of these, and I tried to distribute a power, I can't do that because I'm missing that middle term. I have the first and the last, but I never got my middle term of 16xy. There is a shortcut to having a binomial square, to having a perfect square. You square the first term, you square the last term, and then you double the product. The product of 2x and 4y is 8xy. And if I double the product, I get 16xy. So that is a nice shortcut. Square the first, square the last, double the product. But if I'm going to mess that up, I'd rather write it out twice and just FOIL it. Why am I doubling the product? Because the outside is 2xy times 4y. That's the product. I have the outside and the inside, so I have 2 of them. This really takes us back to completing the square. The rule for completing the square was b divided by 2 squared. And that's the idea that that middle term has to be divided by 2 to be put in 2 places. The square comes into play with the last. All right. All right, we're moving on to some word problems here and application problems for multiplying polynomials. So we have a manager at a plant, and from 1990 to 2005, the number of units produced in thousands can be modeled by this. So n of x is 0.02x squared plus 0.2x plus 3. The average cost per unit in dollars is modeled by c of x. Okay, so this is the number of units, and this is the cost of that. And remember, the number of units is actually in thousands when we have that final number. And then we have our cost in dollars. And so here's that equation. X is the number of years since 1990. And then we want to write a polynomial for t of x. So we've introduced n of x, the number of units produced in thousands. We've introduced c of x, which is the cost per unit. And we want to find t of x, which models the total manufacturing cost. So if I have this many units times the cost for each unit, I just need to multiply that to get the total cost. So I would be taking my function n of x times, let me put a time symbol there, c of x. And so we would write that out. We would have 0.02x squared plus 0.2x plus 3. And we multiply that by negative 0.002x squared minus 0.1x plus 2. Now, in order to actually multiply this out, it is going to be a process we want to use a calculator. We would take the first term times all 3 and write them out. The middle term times all 3, write them out, and the last term times all 3, and we'd add up like terms. So this is what's going to give us t of x. And so this problem, to do the math, is really going to be exactly like this example 2b, We took all three terms and distributed them. All right, for time's sake, I'm going to let you know what this answer is, but at this point you could pause and try this on your own. Again, you would distribute, watch your decimals. The final answer, t of x, is negative 0.00004 x to the fourth minus 0.0024 x to the third plus 0.014 x squared plus 0.1 x plus 6. This would be the total money for the cost. And remember, this was produced in thousands. So we would have to find out what x is, how many years it's been, and then we would plug that in to find the total cost. All right, we have the same idea. The cost of raw materials increased. So we still have the same number of items being produced, but the cost of materials is increased, so we're going to find a new total cost. So we would take t of x and get that by taking n of x, the same equation we had up there, times the new cost for the raw material increase. And again, we would just fill in our information, come back up for n, 0.02 x squared plus 0.2 x plus 3, and we're going to multiply that by our new cost, which is negative 0.004 x squared minus 0.1 x plus 3. Okay, again, I would take all three of these, distribute. It's going to be time consuming because of your decimals, and we put it together. The final total cost would be negative 0.00008 x to the fourth minus 0.0028 x to the third plus 0.288 x squared plus 0.3 x plus 9. Okay, and again, this is the total cost, but remember, the number of units was in thousands of dollars. So we'd have to find out how many years it's been since 1999. Okay, back to some other problems where we are talking about expanding. So it's expanding a power of a binomial. Again, I cannot distribute a power over addition and subtraction. I can only distribute powers over multiplication and division. So when I see this power of 3, I have work to do. I actually need to write this out 3 times. X plus y times x plus y times x plus y. Now, I'm not multiplying all 3 of these at once. What I'm going to do is I'm going to multiply a set of 2 and then come back and do it again. So this, again, is time consuming. So we're going to multiply this first set. I'm going to work on these 2 right here. X times x is x squared. And then I have my positive xy. I have an inside of positive xy. And last of plus y squared. Now don't forget, I still have my x plus y to use. So before I make this more work, I'm going to add like terms. So I have x squared plus 2xy plus y squared. Still times x plus y. Now, if I use my shortcut, square the first term, square the last term, and double the product, I could skip right to here. So you could save yourself a step. Now what I want you to see is I have 3 terms times 2 terms. So you can take the x squared and distribute, and the 2x distribute. I prefer to distribute the 2 terms. So I'm going to work backwards with my commutative property. I'm going to take x times x squared. And I'm going to get x to the third. And I'm going to take x times 2xy, and that's going to give me a positive 2x squared y. And then x times y squared is going to be a positive xy squared. So I just took x times everything and built it up. Then I'm going to come back and take y times everything. So I get a positive x squared y. I get a positive 2xy squared. And then last, I get a positive y to the third. All right, I do need to clean this up. I can only add them if they're like terms, meaning they have to be the same variables with the same powers. So I have x to the third. I'm going to keep that. And I have an x squared here. So there's 2 of them, plus another 1 here. So I have 3x squared y. Then I'm going to go to x to the first. I have an xy squared and a 2xy squared. So I get another 3, but it's xy squared. And then last I get my y to the third. So this is my final answer. And if we wanted to name it, every term is a power of 3 or degree of 3. And so I would call this a cubic polynomial. All right, so I have the same thing here with my 2x minus 1. So I'm going to write it out 3 times. And again, I'm just going to focus on 2 of them and bring this down. So 2x times 2x, well, that's 4x squared. And I'm just going to go ahead and put this together. I get a negative 2x and a negative 2x, so a negative 4x. And then last would be negative 1 times negative 1, so positive 1. So I skipped the extra step and I went ahead and put the outside and inside together. I'm still taking this times 2x minus 1. And again, the order that you multiply does not matter, so I am choosing to take and distribute from the 2x. So this is going to give me an 8x to the third, and then I'm going to distribute here and get a negative 8x squared, and then a positive 2x. I'm going to come back and distribute negative 1 to everything, which is really just changing the sign. So a negative 4x squared, a positive 4x, and a negative 1. So we need to take our time and go through a method of doing this so it's organized. All right, last thing I need to do is add like terms. So I see I have an 8x to the third, that's the highest power on x. I have a negative 8x squared and negative 4x squared, so negative 12x squared. And then a positive 2x and a positive 4x, which is positive 6x. And last is a negative 1. If you look at our next term, we need to write this out 4 times. And then my suggestion is you do the first 2 and the second 2. All right, so we're going to write this out 4 times. 2x plus 1 times 2x plus 1, another 2x plus 1, and our final fourth, 2x plus 1. Now, the shortest way to do this, and it's actually pretty helpful, is to FOIL the first 2, because these are all the same, and when I do that, won't this be the same product? And then I multiply those products. So I'm going to FOIL this first set. 2x times 2x is 4x squared. The outside's 2x, the inside's 2x, so a positive 4x. And last, 1 times 1 is 1. So there's my first product from the first 2. Then I'm going to do the same thing, but since this is the same outcome, I don't have to redo the math. It is right here. And whenever I do these, I always want to clean up and add the like terms. Now, here's where I'm going to take my 3 terms times 3 terms. I'm going to distribute my 4x squared to all 3 pieces. So this is a repeat of what we've already seen. Then I'm going to come back and distribute the 4x to all 3 pieces. And I'm going to come back and distribute the 1 to all the pieces. And then add like terms. To finish this problem, we're going to go ahead and work this out. It's going to take a little bit of extra room. I'm going to go ahead and section this off and work right here. So I'm going to take my 4x squared times 4x squared, which gives me a 16x to the fourth. 4x squared times 4x would be a positive 16, but x to the third. And then a 4x squared times 1 would be a positive 4x squared. I'm going to come back and I'm going to take 4x times all 3 terms. And I'm going to go ahead and stack this one. So 4x times 4x squared would be 16x to the third. So I'm going to pair that up. And then I have 4x times 4x, which would be a positive 16x squared. And then a 4x times 1 is plus 4x. So again, we're not doing hard math, but it does take time and organization. Last, we're going to distribute the 1. So everything gets put here. So 1 times 4x squared is going to be a positive 4x squared. 1 times 4x is going to be positive 4x. and 1 times 1 is going to be plus 1. So I'm going to look at this as a big addition problem. I'm going to add all the like terms, and since my powers are lined up, I have a 16x to the 4th. I have 32x to the 3rd. I have, we'll go with 8 plus 16, that's going to be a 24x to the 2nd. And I have 4 and 4 with x, so 8x plus 1. There are other methods to do this work. You might find that someone shows you to multiply this out with a table, and so I will not take you through all of this, but if I wanted to do this problem using a table to chart it out, I would use this part here, and I would make a 3 by 3 table. And so what I'm doing is I'm going to put the 4x squared up here, then the plus 4x, and then the plus 1. So the signs go with it. If it was a negative 1, there'd be a negative here. Then I'm going to take my next set and run it down vertically. So 4x squared plus 4x plus 1. And I work it just like I do a times table. So I would take 4x squared times 4x squared, I get 16x to the 4th. I would take 4x squared times 4x, which is 16x to the 3rd, 4x squared times 1, which is 4x. If you notice, squared. If you notice, my first set of values lines up with my first set of values. And then I would start again, and I would get my 16x to the 3rd. And you can see that's going to line up here. So all the values in this chart, I'd have 3 rows of 3, and there's my 9 values, and I have 3 rows of 3. So it's another way of organizing your work. If I take you back to when I had example 2a, just in case you want to see this as a chart, I would create a chart that is a 2 by 3. And I'd put the x minus 2 here, so here's x and negative 2, there's my x minus 2. And maybe I would rearrange this and I'd make it a negative x squared, a positive 3x, and a positive 1. I don't have to rearrange it, but you can see again, I would just come through and do negative x to the 3rd, a positive 3x squared, a positive x. Then I have a positive 2x squared, a positive 6x, and a negative 2. And if you can take a minute, I know they're out of order, but you can see I have the x, the 3x squared, the negative x to the 3rd. I have the negative 2, I missed my negative sign, negative 6x, and the positive 2x squared. And then I would go through and add like terms. And again, I would have the highest degree. You can see these are like terms here. Here are like terms, and then my constant. So whether you choose to just distribute it, you choose to stack it, or you like using the box to help organize, those are all ways to multiply out polynomials.